All right, welcome in to percent formula and word problems part 1, everybody. So in this class, we are looking at part 1 of 2, where today our only goal is going to be that formula and working it into word problems. Just one way. There's two ways, going forward and going backwards. Today we're working solely on forward. And so step 1 for us, we're going to start off with memorizing that formula. The first step to truly understanding something is having that foundation. So we're going to memorize that formula through and through. And then once we have a good basis for that formula, then we're going to understand the relationships between those pieces. That way, when we get into those word problems, we're less afraid and less anxious and more excited about identifying what we know. So again, number 1, we're going to memorize that formula. Number 2, understand those relationships. And then number 3, we're going to practice those word problems all the way through for as long as we have here. So with that said, no need to write anything on this screen here because we're going to have 4 pages, 4 slides back to back. So let's go ahead and begin with our core formula. The percent times the original equals the result. So let's just go ahead, take a moment, write that down before we move forward to the next slide, where we're going to do some explanation. All right, so let's move forward here to page 2. Now, what we want to observe here is that we still have that formula right there at the top of the screen. The percent multiplied by the original value, it's going to equal your result. Now, purely from the side of algebra, solving equations, I want us to go ahead and take a look at what we have here. And I just want you to let me know whether you're watching this as a recording or watching this here live with me, say it out loud or in the chat. Let me know when we talk about finding this result. My party people, is it obvious to you, at least with your eyes, is it obvious that to get to the result, we multiply these two values, the percent and the original, we multiply to get to that result? Is that apparent to you? All right, so it looks like, yep, we do understand that to get to that result, we're just going to go ahead, multiply the percent and the original, and we're going to talk about it in a moment in terms of what these actually mean. But I really just want y'all to go ahead and just get your feet wet. To get to the result, we are going to multiply. Now, my party people, on the flip side, when we're dealing with simple equations or complicated equations or any type at all, whenever we're working backwards, if we were multiplying going forward, my party people, what is that opposite operation? When we work backwards from multiplication, yeah, that's going to be division. Working backwards from multiplication is division. And I'm going to highlight that right over here in blue. Now, let me just remind us, again, don't worry about any numbers right now. Just think about the idea. If I was trying to, let's say, get the original value by itself, well, I can't really get it by itself until I remove the percent. And we see that the percent's being multiplied. So if we wanted to get this by itself, we would have to divide. We would have to divide both sides. So that's all I mean. It's just that simple solving equations thing that looks slightly more complicated when we're dealing with, word problems and ideas therein. So before I continue, my party people, does that make sense before we move forward? Just saying, hey, look, if we're trying to find the result, we're working forward and we'll multiply. If we're trying to find the percent or that original value, either one, we got to work backwards, divide one of the others to get it by itself. So one more time, yes or no, does that make sense? Before we move on to page number 3. Good. Right on. So let's now take a moment here to, move forward from that pure math side of things. I want to move forward here and start talking about what the formula actually means. Because remember, everybody, if you've ever had problems with word problems, if you've ever had anxiety about word problems, 99% of the time, it's that you are not confident in your ability to connect the pieces of information. That's pretty much what it comes down to. Now, there's different reasons for it, but the major one is not knowing how to use your formulas. So let's go ahead and go for it one more time. The percent times the original equals the result. That's it right there. Now here's today's main idea. The main idea is The percent that you apply is the result that you get. So notice those particular highlights that I just made. The percent that you apply is the result that you get. And here's a quick example. So to make sure that this makes sense, let me go ahead and just highlight the underneath part as green. Then I'll do blue. And then I'll do, let's just say purple. Or actually, I'll just do green again, because that's what I'm trying to portray. So here's the formula. If you take your discount, multiply it by your original amount, here's your result. Let me explain the numbers now. Let me just make this make sense. In this example, if you are putting into your formula a 25% discount, let me highlight that again, or underline that right over there, and then highlight that in the same exact color. Let me use that red again. Notice on the right side that if I'm plugging in the percent for the discount, everybody, what does the amount represent? Not in dollars. What is that word attached to that dollar amount? We plugged in the percent for the discount, and we ended up getting the result that represented yeah, that's right, Floor, the discount. So I want to keep things as simple as possible. Your formula has three different things: the percent, the original, and the result. The cool thing about this formula is that the percent and the result, when you use this formula, they represent the same thing. So if you plug in a 25% discount, you're going to get the amount of the discount. If you plugged in a percent for the tax, you're going to get the amount of the tax. If you plug in a percent for the final amount, you're going to get the dollar amount that is the final amount. My party people, I know that we're not doing extensive examples yet, but does the premise make sense? The percent and the result, they represent the same idea in word problems. Yeah, and remember, we don't have to be 100% confident. We just need to be sure that we see that connection, that we see that I am pointing to percent and result as connected. Right on. So we'll get into the math here in a moment and how to calculate with percentages. So let's move it over here momentarily for this fourth slide to talk about handling those decimals. So I'm going to read through it, let you take your notes, but we're going to get straight into the first example so that way we can do less theory and actually practice and actually go through the mistakes, make the mistakes, and then grow from them. So when we're multiplying by a percent, like you see right over here, when we're multiplying by a percent, we got to turn that percent into a decimal. So what that means is we're going to move the decimal twice to the left. Let me just exemplify that for you. Let me make your life easy with no stress. So let's say I have 25%. Well, before I actually apply 25%, we have to apply it as a decimal. So all we need to do, my party people, is take that little decimal right over here and move it over twice to the left, meaning we'll be dealing with 0.25. And notice, always moving that decimal twice to the left. This does not depend on what you see. No matter what, you're always moving it twice to the left before you multiply by a percent. So you might have the question, hey, what if it's 3.21%, right? That's a pretty good example there. So if we have something like, let's say 3.21%, everybody, does it matter that we see it like that? How many times are we still going to move that decimal? How many times? Twice, exactly. We are always going to move it twice. But I can agree with you if you believe that it's going to look a little funky. And this is where a lot of people end up making a very common mistake. So pay attention here. Let's grab that decimal place and let's do it twice to the left. Once, two, okay, that's a little awkward. My party people, if I put the decimal place where I think it belongs, I'm looking at a blank space. And that's a little confusing. But everybody, if there's a blank space there, what number can we assume belongs in there? Yeah, that's going to be a 0. So 3.21%, before we multiply it, it's going to turn into the decimal 0.0321, like this, 0.0321, just like that. Remember, no matter what, always moving the decimal twice to the left when we multiply by a percent. So with that said, my party people, does it give you a little more confidence in terms of how we're supposed to handle that conversion before we multiply? Right on. Slow and steady. Slow and steady. And so this is the second part here where we'll be talking about this a little more in that follow-up session, when the next one after this one, where when we're working backwards and we're trying to find that percentage, what's going to happen is you're going to end up with a decimal first. And so you got to go backwards and turn it into a percent again. To do that, it's the opposite. So for example, if we are, if we have 0.25 and we got to turn that back into a percentage, no worries at all. What we're going to do is we're going to move it to the right twice. So if we start right over here, 1, 2, and so that becomes 25%. So you can go forward and backwards super smoothly just by making sure you know this rule. It's always going to be twice. Now, I want to make sure I'm very careful when I say this, because this is only when you are converting percentages to decimals and decimals back to percentages. There is a rule that we follow when it comes to multiplying the actual decimal. My party people, are you hearing me? Give me a yes or a no. This specifically, what you see on this screen, this is for converting. Again, converting the decimal into a percentage and a percentage back to a decimal. That's what this is. We will talk about now in this next screen, right over here. We are going to talk first now about how to actually calculate with those decimals after we make that conversion. So let's go ahead and do that here. We see that it says 15% of 200 is what number? Now, before I even get started here, before we even get our feet wet and get this going, can somebody tell me, when we look at this, are we trying to find the percent, the original, or the result? And how do you know? Looks like some say the original, some say the result. Now we have a lot more folks saying the result that we're supposed to multiply. Right on. Let's go ahead and understand how we got there. Remember, everybody, when it comes to that formula, it's going to be a really good guiding force. So that formula is going to be the percent times the original equals the result. I think we've said that at least 50 times in today's session. But what I want to point your attention to is translating some of these pure math words, see, these operational words. Everybody, I know that the word out of is a way to say division, but can somebody tell me what the word of means? I already see in the chat box. Yeah, for sure. All of us are saying the word of translates to multiplication. So when you check things out, look at how this sentence is written. We have this percent already right there. Percent times or of, they mean the same thing. And that means that the 200 is that original number. And if you're still not sure, everybody help me out. The word is, what does that translate to? The word is translates to that equal sign all the way through. So with that, yeah, look at this. What number? Well, this is that number, the result. That's what I'm looking for. So before we get into the high stress of word problems, can we all agree before we do this example that, yeah, this fits the bill because we are taking the percent of a number and we're trying to see what that result is. Let me know if that makes sense to you before we get started on the actual calculation. All right, sweet. Sounds good. So let's go ahead and, again, wrap our heads around the actual calculation here. We have 15% multiplied by that original value, which is given to us as 200. And we want to know what that result is going to be. So what did we say we would do first, everybody? We have to do what? We have got to make sure, yeah, that percent, we got to make sure that that percent turns into a decimal. How many times did I say we have to move that decimal place over to convert? Twice. What direction? Twice to the left. There we go. So with that, let me just show you what that's going to look like. We're going to take that decimal place, move it over once, twice, and there it is. So now we have 0.15 multiplied by 200 equals the result. All right. Now it's time to go ahead and multiply by that decimal. So let's remind ourselves how to do that. We'll have 200 multiplied by 0.15. So here's a quick little reminder, quick little rundown. We're going to go ahead and write this here at the top right of the screen. We're going to say to multiply by a decimal. Let me just use a little line right there. So multiplying by a decimal. We have 2 steps to follow, and it's going to be super straightforward, really easy. As long as you have this written down somewhere, as you practice, this will become second nature very quickly. Step 1 is just to multiply like normal. Multiply normally, because we're going to ignore the decimal, okay? Multiply normally, ignore the decimal. And then step 2, after we're done multiplying, after we're done ignoring that decimal, we are going to bring those decimal places back. So we're going to bring the decimals back right there. So let's follow this little plan, see what we have, and we're going to move forward. So here we go. Let's multiply like normal. We have 0 multiplied by 5, which is going to be 0. 0 multiplied by 5, that's 0 again. Then we have 2 multiplied by 5, and that's going to be 10. Now we're going to move forward over here to the 1. So we're going to start writing right over here. So first off, we have 1 times 0, 0. 1 times 0, 0. And then 2 times 1, that'll be 2. We add this back up and we get 0, 0, 0, and 3. All right, everybody. So my answer here is 3,000, or what am I forgetting to do? Yeah, we have to bring those decimals back. We have to bring the decimals back. And here's how you do that. We're simply going to say, hey, up here, any decimals? Nope. But how about down here? Yes, we have 1, 2 decimal places. Coincidentally, I know earlier we always said we're always going to move it twice to convert. But here, you always count the number of decimals that you have. It could be 1, could be none. Could be 2, 3, or 7, who knows? But you will count the total number of decimal movements up here, and you will bring them back down here. There's 1, there's 2, and so our answer here, our result is 30. 15% of 200 is 30. So that's a little bit to unpack there, right? But just as a recap, remember that our formula is the percent times the original equals the result. If you're trying to find that result, you just multiply the percent in the original. But again, don't forget, we have to convert that percent to a decimal by moving it twice to the left. And then to actually multiply by a decimal, again, it can feel overwhelming, but I got you every step of the way. To multiply by a decimal, we're going to multiply normally, ignoring that decimal, and then we'll bring the decimal back at the end. As long as you follow these small but very important steps, we can build our way up to working on these word problems without much of a hitch. So with that said, my party people, how are we feeling? We're ready to move forward to another example problem? Let's move forward to another example problem. So in this case here, we see that it says, what number is 60% of 320? All right, so let's try this out here. First things first, do we know what we're looking for? Are we trying to find the percent, the result, the original? What are we trying to find here? Who knows? Oh, still trying to find the result? Yeah, I agree. Absolutely agree. Now let me describe why. We know that we're trying to find the result here. Let me actually just write the formula down again. Again, percent times original equals the result. And let me give myself a little more room there, a little more grace. Equals the result. So we know that there are some key words like of, like is. That's really going to give things away. So when we check this out, what number? Okay, so I'll just translate that to some blank. What number? Then we have the word is. Help me out, everybody. The word is, what does that mean? Yeah, that's the equal sign. And then right over here, this is the rest that we need. 60% of 320. The word of, we've talked about this, it means multiplication. So with that said, this would be 60% times 320. So 60% of 320 gives us that resultant number. This example is just a quick exercise in showing you what happens when you flip that equation. So instead of saying percent times original equals result, you can still absolutely say result equals percent times original. Remember, everybody, if 1 plus 1 equals 2, then 2 equals 1 plus 1, right? So you can write it either way, and I want you to be comfortable with writing it either way. Before we get to the calculating, does that make sense? Give me a quick mental check. Does that make sense to you? We can write the equation, flipped or the normal way. It still means the same thing. Perfect. Now let's move forward here. Let's get this multiplication going and let's keep it going. So let's zoom on in and let's write out the 60% as a decimal. First step is locating that decimal, which is going to be right over there. And we're going to move it over twice. So once, twice. So that's going to give me 0.60. That's the same thing as saying 0.60 or 0.6. That extra 0 at the end, you really don't need to write it when it comes to decimals because 0.60 and 0.6 are the same exact number. So before I continue, let's go ahead and just rewrite it as 0.6. Again, you can have 0.60. It's the same exact thing. You're going to get the same answer that I'm going to get. And we're going to multiply by that 320. Now let's move it over and let's go ahead and do it. 320 multiplied by 0.6. Let's perform the math here. We have 0 times 6, which is going to give us 0. 2 times 6, and that's going to give us 12. Carry that 1. Then 3 times 6 is 18. Carry the 1 is 19. So there we are. We have seemingly 1,920. But my party people, in this specific example, I know on your paper you might have used 0.60, but here I'm just using 0.6. How many decimal places am I bringing back here? Yeah, it's not going to be 2. It's actually just going to be 1. In this specific example, remember, when it comes to multiplying by decimals, we bring back the number of decimal places that we ignored. In this specific setup, we only have 1 decimal place that we move right back right there, which is going to give us 192. That right there, my friends, is the final result. Remember, if we had 0.60, let me actually just write this out over here. If we did 0.60, what we would have ended up getting when we did all the math is 19200. You would have had this. And what you would have done was 1, 2 decimal places right there, 1, 2 right there, and you still would have gotten to the same correct final answer. So it really just depends on what you specifically have in the multiplication that you're doing. Notice that that's different than the mandatory rule of always converting by moving twice. Again, this is a mandatory rule. This one is a little more flexible when it comes to multiplying by decimals because it depends on your setup. Right on. I'm seeing that it makes sense in the chat box, starting to make sense there. That is a good thing for me. But there's our answer for this problem. That is 192 as the result. So with that said, my party people, I think it's time for us to take it forward here and start incorporating this into that main idea. And that main idea that I expressed was the percent that you apply is the result that you get. So let's go ahead and dive in here. Let's take a look at our first multiple choice question here for this topic. So it says here, a restaurant bill is $68. You leave a 15% tip. How much was that tip? Let's go ahead and get into this one. So the one thing that I'll always say is I should not have read that problem from start to finish. The one thing I always say, I'm always, really digging into your brains about, is that we must understand the question sentence first. So read the question first. RTQ, read the question. How much is the tip? Everybody, this makes life a lot less stressful because you're opening up your problem solving. You're opening up your problem solving with the goal in mind. If you stay goal oriented, you will reach that goal sooner. So how much is the tip? Okay, cool. So I want to know how much the tip was. So I'm going to say tip, some number of dollars. I know it's dollars because I see the answer choices, and so I'm good there. So now that I know what I want to know what I have. That's step 2. What do I want? What do I have? What's the connection, right? So I know what I want. What I have here, it says a restaurant bill is $68. So let me write that out. The bill equals $68. And then it says you leave a 15% tip. Okay, sounds good. Let's write that down. Let me just move this down here and say that I left a tip equals 15%. Now, I am going to ask one question, and I want you to either, if you're here live, type it out. If you are by yourself, go ahead and yell it at the top of your lungs. My party people, what is the main idea with that percentage formula? So the main idea is the percent that you apply is the result that you get. So if I write that formula out, percent times original equals the result. This is exactly what we mean here, everybody. What we mean by that main idea is that the percent that you plug in right here, it's going to represent the result over here. So everybody, quick question. If I'm looking at what I want, give me one word, or 2 words actually. What am I trying to find at the end of the day? What am I trying to find at the end of the day? In this specific problem, I want the result. And that result represents what? I want the result, and it represents what? Yeah, it represents the tip. It represents the tip. So if I am to try to find the amount of the tip, what this means, everybody, and I hope that this opens some eyes. What this means is that the percent that we plug in right over here, the percent that we plug in, this has to represent the percent of the tip. This is where we start getting into those questions where, if they're asking you for the sale price versus the amount of the discount, this is how you know what you're actually supposed to plug in. Because I want the amount of the tip, I am going to plug in the percentage of the tip. And everybody, what was that percentage of the tip that we're given here? Yeah, the percent tip that we're given is 15%. So what we're saying is 15% of that bill, of that $68 bill, is going to be the amount of the tip. Again, if you multiply by the percent of the tip, you'll get the amount of the tip. That straightforward right there. So with that, let's do the calculation. Let's see if this will lead us to the correct answer, and then we'll continue moving forward. So here we go. Let's zoom on in. All right, let's get this done. 15% is going to turn into what when we try to calculate? 15% is going to turn into a smooth 0.15. That's right. We're going to end up getting 15% going left twice. And so we have 0.15. And then from there, we're going to multiply by that 68. And so what we need to do is we need to go ahead and just set this up. I'll just do this here on the side. We'll ignore that decimal place, multiplying like normal, and then we'll bring those decimals back at the end. So 8 multiplied by 5, that's going to be 40. Then we have 6 multiplied by 5, which is going to be 30. Carry the 4 is going to give us 34. Then from here, we're going to put a 0 because we are moving to the next place value. So we have to start where it is. So now we have 8 times 1, which is going to be 8. Then we have 6 times 1, and that's going to be 6. Add everything back together, and we're going to have 0. 4 plus 8 is going to be 12. 3 plus 6 will give us 9. Carry the 1 gives us 10. But we're not done, because the last thing that we must make sure to take care of is what again? Yeah, we're going to bring the decimal places back. In this case, we see that it's 1, 2, 1, 2. And so there it is. Our final answer is going to be $10.20. That, my friends, is going to be the amount of the tip. So one more time, everybody, let's make sense of this. We have to make sense of this. What I am saying here is that the percent that you plug into the formula represents the result. So you can use that to your advantage. If I'm trying to find the amount of the tip at the end of the day, hey, that means that if I plug in, if I know what the percent of the tip is, I'm good, because that percentage will lead me to the corresponding amount. Does that make sense, everybody? Before we continue and keep having fun? Again, I'm going to repeat that a million different times as you go through this lesson. All right, so with that said, let's go ahead. Let's keep it going here. Let's take a look over here. Let's take a look at our next problem. So we're going to read the question first. It says, how many pounds should be removed? All right, everybody. So no matter how confident we feel right now, the one thing that we can be confident about is our ability to read a sentence. In this sentence, how many pounds should be removed? Can you give me a short phrase as to what we're looking for here? What are we looking for in this specific example? And I don't want you to talk about it in terms of the result or percent or the original. I want you to talk about it in terms of just a story. If we're reading the story, what are we trying to find at the end of the day in terms of the story? Yeah, we were trying to find the number of pounds that we have to take out, that we have to remove, the number of pounds that needs to be removed. So again, before you get to the math stuff, before you overwhelm your stuff with that, you want to begin simply with the story. What is the story saying I need to find? Once I know that, okay, some number of pounds that needs to be taken away, removed, sounds good. Now let's read the story, the other pieces of information, so I can connect the dots. So with that, let's go ahead and see what we say. A soldier's backpack weighs 40 pounds, but must be reduced by 12.5%. Okay, so let's see what we have and what we're looking for. We want to know that we have some pounds that are to be removed. So blank pounds removed. That's what we want to find out. And then we see that the backpack initially weighs 40 pounds. So I'll just say backpack weighs 40 pounds. And then we see here that it says it must be reduced by 12.5%. So I'm going to write that down. I'm going to say 12.5% reduction. Now, this is where, if you don't think that vocabulary matters in math, it does. My party people, can you tell me what two words on the screen that I've written mean the same thing? Which two words that I've written on the screen mean the same thing? Hint, hint, they both start with R. Yeah, removed and reduction. These mean the same thing, everybody. If I'm trying to reduce by a certain amount, that means I'm removing a certain amount. Before I continue, does that make intuitive sense? Removing and reducing in this sense, in this problem, they mean the same thing. All right. Now let's go ahead and think about the formula here. Let's think about that formula. The percent times the original amount equals the result. Let's get a little deeper here. We want to find what? The number of pounds that we are removing. So let's go ahead and write that down right here. I want the blank pounds removed. Everybody, let's take a look at that percentage that we were given. Does that percentage represent removing? Yes, it does. Reduction, 12.5% reduction. So we're taking off 12.5%. So if I write that down here, it's a 12.5% being removed, which is going to give me the amount removed. So before I continue, does that make a little more sense, everybody? The percent that we're applying will represent the amount that we get. And so if we have that connection, we want to plug into the formula with that connection. And don't worry, if you think that all these problems are going to be like this, get ready. They're not. But we have to pay attention now so we don't get got later. Yeah, we're going to talk about that decimal movement for sure too. So remember, the original amount, it represents what you have at the very beginning. Before any alterations, before any changes, this is where that original amount comes into play. And that's right over here. That backpack, before anything was done, it's at 40 pounds. So I'm going to write that 40 right over there. So once we're here, this is where we shift from, hey, we worked through that understanding in the formula, and now we're just going to apply that formula. So let's get it done here. Boom, let's zoom on in and let's write it out. We have 40 times 12.5%. Everybody, what is that 12.5% going to turn into? When we move that decimal place over, we're going to do once, twice. So yeah, that should be 0.125. That's going to be 0.125 multiplied by 40. And so what we'll do is over here on the side, we'll calculate. And one thing that I'm not going to play around with is that we have 1, 2, 3 decimal places right over here. So let's go ahead and do that. First, 0.125 on the top, and we'll multiply by the 40 on the bottom. Again, remember, 1 times 2 is the same as 2 times 1. So the order doesn't matter. I'm just being smart about it because I don't want to have this on the bottom and then have to write 3 separate lines. I'm not trying to do that. I'm going to avoid all that work. So let's go ahead and get it done. 5 times 0, 0. 2 times 0, 0. 1 times 0, 0. That's easy. Next up, we're going to go to the next line, placing a 0 so we can start at the proper place value. And so we have 5 times 4. That's going to be 20. Carry the 2. Then we have 2 times 4. That's 8. Carry the 2. And that'll be 10. Carry the 1. Then we have 1 times 4, which is 4. Carry the 1. That is 5. Add everything back up. And we're going to get 0, 0, 0, 5. And at this point, we should always, always, always bring back 2 decimals, right? We're always bringing back 2 decimals, right? Come on, blindly agree with me, please. No, that's right. We're not going to do that. We're not going to do that. When it comes to multiplying by decimals, we got to be patient. And we have to understand that we are bringing back as many decimals as we ignored. Yeah, exactly. In this case, we have 1, 2, 3 here. We have none over here, so just, kind of cross that out. So we have 3. And so what we're going to do is 1, 2, 3. So the answer is not 5,000 or 500 or even 50. The answer is 5. That's what we're going to get. And so the answer choice that's correct is answer choice C. 5 pounds. The soldier needs to reduce or remove 5 pounds from his backpack. So now that we're contextualizing this, I hope you're starting to see the connections here, especially with the formula. The percent that you apply is that result that you get. So with that, let's gear ourselves up. Let's gear ourselves up to another one, and let's keep having fun. All right, here's a problem. The problem says, and again, we're going to start with the question sentence first. Again, the question sentence right over here. It says we are looking for the sale price. What is the sale price? Let's take a look at this one and let's understand for the first time in this session maybe why this mistake happens so often. And we'll talk about that mistake coming right up. So it says, what is the sale price? Can anybody tell me what sale price means? What does it mean to be looking at a sale price? What does that mean? If we're thinking about it as shopping, is it the price that you see when you look at the item initially? Is it the price that is removed from that price that you see? Is it the price that you pay at the end at checkout? What does sale price mean? What does sale price mean? There we go. Yes, here in the live class, Apollo, that is correct. Sale price is the final price that you pay. It's the price that you pay at checkout. Does that make sense, everybody? The sale price is the price at the point of sale. So once you actually sell it, that is the price that it was sold for. Okay? Sale price is the price that it's sold for. So I'm going to write that here. We are looking for the final price. Blank dollars, right there. We are looking for the final price. Now, because we are looking for the final price, everybody, let's just take down the information that we currently see. And I want to see who can point out what's wrong with this. What's wrong with this relative to wanting to take the easy way and just plugging and chugging. Show me and tell me why this should give you pause. I see here that the jacket that we're looking at, it originally costs $80. Okay, so I'm going to say original price. That's going to be $80. Okay, sounds good. And then we see that it's on sale for 25% off. Okay, so it's 25% off. So here's the big thing, everyone. If we're trying to apply this formula universally, percent times original equals result. If we're trying to apply this formula properly, here's why a problem like this will get a lot of people in the wrong place. Because most people will think that, oh, I have the original, I have a percent, I must plug these in and get the result. This is what most people just blindly do. But let me show you with what we've learned in this lesson, what's actually supposed to happen. So look, we have 25% times the original $80 is going to equal the result. Can somebody tell me what that 25% represents again? Can someone tell me again what that 25% represents? Yeah, 25% off means a 25% discount. One more time. 25% off, that means that it's a discount. All right, sounds good. Now, I'm going to ask a very hopefully obvious question, but if you don't know it, it's all good, but say it at the top of your lungs or type it in quickly. What is the main idea behind the percentage formula? What is the connection between those, pieces that we see in the formula? What's that main idea? Give it to me. The percent that you apply is the result that you get. Check this out, everybody. If I am plugging in 25% and that represents a discount, think about it, everybody. Think about it. If this represents a discount, what is the result going to represent in this specific setup? If the percent represents a discount, what is the result going to represent? So for those of us thinking that it's the final price, it can't be. It cannot be true. Because remember, the percent that you apply is the result that you get. In this specific circumstance, if we set it up like this, we would get the amount of the discount. This is how the formula works. This is why some of us use the percent formula and oftentimes don't understand where our mistakes come from. And it's this right here. This is the most important part. It's simply because the percent that you apply is the result that you get. And if you don't believe me, let me prove it to you because I'm going to solve this problem in two different ways. So hang tight. Let me go ahead and show you this first way, everybody. What happens if we just plug in the 25% right over here? What happens if we just do that? Look at what happens. 80 times 0.25. Let me show you what happens right over here. I got you. Everybody, 0 times 5, that's going to be 0. 8 times 5, that's going to be 40. Then we'll move over right over here to the 2. And we see that we'll get 0 times 2, that's going to be 0. 8 times 2, that's going to be 16. All right. We add all of this together. We get 0, 0, 10, carry the 1. 1 plus 1 is 2. We bring back 2 decimals, and here's where this gets juicy. Bring 2 back, and that's $20. Everybody, can we confirm that? Can we confirm that? This is $20. Okay, sounds good. So if we plug that $20 in, if we plug that in right here, Everybody, is $20 the final answer? Is $20 what we're going to pay? No, it's not. What does the $20 actually represent, everyone? What does the $20 actually represent? The $20 represents the discount, the amount that you're taking off. Now, notice with your eyes, confirm visually with your eyes right over here. The percent that we plugged in represented the discount, which means by rule, the result that you're getting in this setup is also going to represent the discount. So because of that, we have to take a quick extra moment and think about, okay, I just calculated. I did not get what I was looking for, but what could I do given that I have the original price of the jacket? What could I do to get the right answer? Exactly, I could subtract. Because, my friends, if my original amount for that jacket is $80 and I subtract the discount of $20, I get a final price of what? Yeah, I get a final price of $60. That's my final price. That's what I want. And that's why our correct answer is going to be A. But before we move on to the next one, my friends, my party people, wouldn't it be nice if we didn't have to, do more work after already calculating with the formula? Wouldn't it be nice if we didn't have to go in circles like that? Yeah, I think it'd be nice for a lot of us to just know the direct way to get this done. And this is how we're going to get it done. I got you. Let me just make this a little smaller over here. And we're going to do this same problem a second way. I got you. Let me put that over here. And we're going to base it off of the same thing, the same formula. The percent times the original equals the result. And because of our main idea, the percent and the result representing the same thing, watch how I'm going to do this. I'm going to first begin by identifying that I want the final price. Let's start right there. I want the final price. So let's write that down. Equals blank, whatever dollar amount, but this represents the final price. Everybody, I already know that my jacket was originally $80, so I'm going to plug that in. What I have to modify, though, is the percent, because the percent and the result, they have to represent the same thing, right? That's all I've been saying. I've said it 40 times. I've already drinking like 2 cups of water. My voice is gone at this point, but it's worth repeating if it helps you learn. So look, if my result needs to represent the final price, the percent that I plug in needs to represent the final price. How do we get that? Easy. Everybody, quick question. What was that percent of the discount? Help me out again. That percent of the discount, that was what again? That was 25%. Yeah, let me move that over. Let me get this going here. Yeah, that's 25% off. Okay. Let me take this exact thing right over here. Let me take this exact little equation I wrote and let me make it make sense. That discount was 25%. Everybody, what percent represents the original in any case? What percent represents the whole thing? The entirety of what we could have? Yeah, 100. 100% represents the original. So with that, let me just move this so you don't get confused by that. Let me just move it up a little bit. But take a look here. Earlier, when we were just looking at the money, we saw that the original minus the discount gave us that final price. Take a look over here. The original percent, which is always going to be 100, minus the discount is what? Everybody, what's 100 minus 25? 100 minus 25, yeah, that's 75%. Take a look at that. So everybody, quick question. Can you tell me in the chat box, what does that 75% represent again? What does that 75% represent again that we needed? It doesn't represent the discount. That was 25%. When we take away the discount, we end up with the final. Yeah. So guess what, everybody? I am willing to wager that if we take that 75% and we plug it in. Watch the beauty that happens. We're plugging in 75% because it represents the final percent. Now watch this happen. Watch this magic. Let's go ahead and calculate. We have 80 multiplied by 0.75. And here we go. 0 times 5, that's going to be 0. 8 times 5, that's going to be 40. Then we'll draw a 0 there, move it to the next line. 0 times 7, that's going to be 0. And 8 times 7, that's going to be 56. Look at what just happened. 0, 0, 4 plus 6 is 10. Carry the 1. And that'll be 6 moved over. We have 2 decimal places that we will bring back. And so we'll bring 2 back. Right there. Everybody, quick question. I just got $60. It's almost like I've seen that number before. It's almost like I've seen that 60 before somewhere that represented that final price. It's almost like have we seen that number before, everybody? Is that 60 the final answer? Y'all tell me, because again, I'm bad at math. Can y'all tell me if that seems familiar? Yeah, there it is. So remember, everybody, it's not just about knowing your formulas, it's knowing how to apply them. And when it comes to percentages, the percent and the result in your setup, the percent and the result represent the same thing. So in a problem like this, where what you're looking for and the percent that they give you represent 2 different things, again, this is the discount and we're looking for the final. Because they represent different things, you might be well served to take a moment to try to understand what that percent could be to make sure it lines up with your final amount. Seriously, you want to start with what you're looking for, final price, and that'll dictate what percent you want to plug in, the final percent. And if it just so happens that you forgot to do that, no worries. In the first iteration of us doing this problem, we just went ahead and just subtracted at the end, and we got the same correct answer. So it's up to you to determine which method you prefer, but I need you to understand that the percent and the result in any setup that you have must represent the same thing. My party people, does that make sense before we continue to the next one? Let's handle this next problem here. So we see that it says a city of 120,000 people, yada, yada, yada. I don't care about all that. Remember, begin with the question sentence, and it says, how many new residents is that? So remember, the first step, not the math, the first step is context. What is the story telling you to find? New residents. That's what I want. I want the number of new residents. So everything I do in this problem, whether it's a percent problem or not, it's going to be centered around getting the new number of residents. So what do we know? We know that we have this city of 120,000 people. Okay. We have 120,000 people. Okay. And then it says it grows by 3%. So we see that we're going to write down 3% growth. And now the only question we have to ask ourselves here is, are the percent and the result available for us in this problem, everybody? Are the percent and the result, when we set up this formula, will they represent the same thing? Because remember, main idea, the percent that you apply is the result that you get. These 2 ideas represent the same thing. So if I were to plug in the 3% for the growth of this population, everybody, is that going to be the same representation on the right side? Yes or no? And in this particular example, the answer is going to be yes. Absolutely going to be yes. Because when we think about them, it's saying, hey, look, the population is growing by 3%. That means that this 3% represents the new number of people that are going to be in this city. Again, it's more important to pay attention to the words than it is the actual numbers. So if the population is growing by 3%, it's going to grow by this number of new residents. So yeah, that's actually what I want. Blank new residents. Yes, because 3% is going to be the population increase, which means it's going to be new residents, 3% new people, blank number of new residents. So we're good to go. The last thing I need to understand or just plug in is that original value. Everybody, what was that city's original population? City's original population is going to be right over here. Bam, 120,000 folks. That's right. So now that we have the 120,000 folks, we'll multiply by 3%, which is the same thing as saying 0.03 after we move that decimal place over twice to the left. So now that we have that, we're good to go. Times 120,000 right over there. And let's do the work. 120,000 multiplied by 0.03. And so with that, the reason, just want to remind everybody, the reason that this is not going to be 0.3 is because, remember, we always move the decimal place twice when converting. So not just once, not going to be just once right here, but we have to go twice to create that 0. So it's 0.03, not 0.3. So moving on, in the final calculation, we're going to have 1, 2, 3, 4 zeros. 1, 2, 3, 4. Then we have 2 times 3, which is 6. 1 times 3, which is 3. We are going to now bring back 1 and 2 decimals. And so we'll do once and twice. So the answer here will end up being 3,600 or 3,600 new residents coming to this city. And that's why the correct answer for this question is answer choice B. So with that, who's ready for another one? And let's tackle this practice problem. Here we are looking at the question sentence saying, how many still need to be printed? So again, it says if 60% are already printed, how many still need to be printed? So let's highlight that. How many still need to be printed? Everybody, if I'm asking how many still need to be printed, is it safe for me to say that we want to find how many are left to print? Is that fair to say to you? Yeah, we're looking for how many are left to be printed. So there are two ways to really go about this. Number one is going to be to just blindly plug things into the formula. And the other method is going to be plugging in the percent that corresponds with what we want. Watch, two ways. Here's number one. Let's just blindly calculate. If we do 60% times the original 150 flyers equals blank. Everybody, quick question. What does that 60% represent? What does that 60% represent? Who knows? Ooh, I love that right there, that comment. Already completed. Yes, right over here. 60% are already printed. So already printed. Already printed. What does that mean, everybody? It means that over here, we're going to get the number that have already been printed. See, this is what happens when you just take a look before you begin, because you might notice if you're on the right path or not. Let's calculate and see what that's going to turn into. So the 60%, 2 decimal places over, that'll end up being 0.6 or 0.60. They're the same thing, everybody. They're the same thing, but we have 0.6 times 150. Once we perform this calculation, we're going to end up having 150 multiplied by 0.6. Once we do that, we have 0 times 6, which is going to be 0. 5 times 6, that's going to be 30, carry the 3. And then 1 times 6, which is 6, carry the 3, is 9. And so we're going to bring back just 1 decimal place here. So that's just 1 decimal place right there. And that'll give us 90 right there. Boom. So we get 90, but we have to ask ourselves, is that the actual answer? Everybody? Is that the actual answer? Not at all. No. This 90 represents the amount that was already printed. That's not what we're looking for. We're looking for how many are left. to be printed. So because of that, we can subtract naturally here. We can subtract and say 150 flyers that we need minus the 90 that are done will give us 60 left. And so sure, the correct answer is going to be B, 60. But notice how if we blindly go in with the numbers that we have and the formula that we know, we will definitely get this wrong if that incorrect answer is listed already. So with that, again, let me show you the right way to do this one. Let me show you the correct way. Let me show you that the percent times the original equals the result. And the percent and the result represent the same. So if I want the percent, or if I want the result to represent how many are left, we need to plug in the percent that is left. Everybody help me out. Help me out. Let me just fill in that 150 real quick. Help me out. If 100% is the original number of flyers in percent form, and I already have 60% printed, how many are left? Yeah, 40. 40% left. So now that we have that proper percentage, we can plug it into the proper place. And now we know that because we are calculating with the percentage left, we know that we'll get the amount of flyers left. Yes or no in the chat box, or give me a nod if you're watching from home. Does this make a little more sense here? Is the formula starting to shape up to something that's actually understandable? Good. Good. And this is where, again, plenty more practice needs to come in to really drive this home. But let's get it done here. Let's do the final calculation to show you how smooth it is. 150 multiplied by 0.4. We're going to end up having 0 times 4. 5 times 4 is 20. Carry the 2. Then we're going to have 1 times 4 is 4. Carry the 2 is 6. And so the last thing we do is 1 decimal place over. Boom. And our answer is 60. The same answer that we would have gotten going this really, really long way, but we did it in less time and less effort. And there we go. Again, it's about understanding the formula first, because from there you get to understand what to do next. All right, and this next question asks us how many vehicles are left. So, one of the things that we really want to orient ourselves around is that question sentence. Not how many vehicles are there, how many vehicles are left. Keywords, they're very important. So we have here, we want to know blank vehicles left. And when we take a look at the information that we're given, let's line things up. A mechanic has finished 35% of a 60 vehicle inspection. Okay, let me write this down, everyone. Let me write this down. We see clearly that it says we finished 35% of a 60 vehicle inspection. So what that means is 35% of the original 60 vehicles equals finished, equals the number of finished vehicles in terms of the inspection. My party people, I have a question. I have a very, very straightforward question. If I went ahead and just used this formula, this setup, will I get the correct answer immediately? Will the first number I get when I calculate be the correct answer? No, it will not. Because again, the percent that we apply and the result that we get must represent the same thing. In this case, they do not. We see that it says 35% finished. So that means that the result is what is finished. So because of that, we will not get the correct answer with this formula. Let me move that out of the way. Let me get a formula that will give me the correct answer, which will be representing the vehicles left. So the percentage that is left times the 60 vehicles will give me the number of vehicles left. So I'm going to start off with 100% because 100% represents all vehicles. It represents all of them. And if I take away the number that are finished, or the percent that are finished, that's 35% that are finished, that's going to give me the percent that is left. Again, it's all about that formula here with percentages. And so 100 minus 35%, that's going to be 65%. So what we know about this is that we have 65% of the vehicles left. Now, if you're sitting here at this moment in time thinking, hey, now's a great time to switch my answer so coach doesn't notice, I noticed. I did. And it's okay. So let's go ahead and work through that. We got this. So 65% left. Then we'll plug that in. So zoom on in over here to do the calculation. And so we'll have 60 multiplied by once, twice, 0.65. Let's multiply. And here we go. 0 times 5, that's going to be 0. 6 times 5, that's going to be 30. And then we'll move over to the next line with a 0 instantly there. So then up next, we have 0 times 6, 0. And then 6 times 6 is 36. Lined it all up. And now we add everything. We have 0, 0, 9, and 3. So it's not 3,900 because we have to move 1, 2 decimal places back. And that'll be 1, 2 decimal places there, making it so that we have 39 vehicles left in this inspection, making the correct answer here, answer choice B. So let's take a look at this new one here. So the question sentence reads, how many visitors this month? So specifically, how many visitors this month? Okay, sounds good. So when we take a look at the information that we have, we see that it says, last month, the website had 12,000 visitors. Okay. So I'll just say 12,000 visitors last month. Okay. And then it says this month, the visits grew by 18%. So I'm going to say 18% growth. Okay. Perfect. So before we get to calculating, before we start throwing numbers together and hoping for the best, let's understand the situation. Everybody, what do we want? At the end of the day, what is it that we want? Do we want last month's visitors? Do we want the number in the increase? Or do we want something else? Yeah, we want this month. That's what we want. We don't care about last month. We don't care about the amount that they grew by. I just want to know that final amount for this month. Now let's think about how to get there. So again, I want the number of visitors this month. So blank visitors this month. Now let's discuss how to get there. Let's think about this naturally. We don't want to think about this too complicated. It's a very straightforward approach. If we had growth, then it sounds like what we want is last month plus the growth is going to give us this month. So can anybody tell me if that makes standard sense to you, generic sense, that if I'm trying to get to this month and I have last month and I have the growth, I add those together and that'll give me this month. If I start from last month, I add the growth, yeah, I'll get this month. Now, there are two ways that we can do this. As you may have seen, if you're in this lesson, as you may have seen with how we calculate those final amounts, sometimes we work with the values and sometimes we work with the percentages. We can go either way here. So if we think about in terms of percentages for last month, well, that's the original amount, which would be 100%. The growth was 18%. So that final percent would end up being 118%. But remember, everybody, pop quiz question of the day. When it comes to working with percentages, calculating the percent of the original amount, what operation is that again? What operation is that? The operation is going to be multiplication, right? To get that resultant value, we're going to be multiplying. Now, why do I bring that up? I bring that up simply because I do not want to multiply by a 3-digit number. I do not want to multiply by a 3-digit number. So instead, here's what I'm going to do. Instead of multiplying by a 3-digit number, I am instead going to say, hey, I'm going to start with last month, the 12,000, and I'm going to add whatever that growth is, and that'll give me this month. But I first need to figure out what that growth amount is. So watch how I'm going to do that, everybody. To make my life a little easier, I'm going to come over here and I'm going to do the 18%, which is the growth times the 12,000 visitors last month. And that's going to end up giving me whatever that result is, but that result is going to represent the growth. Let me move that over so you don't get it confused with what's above. But that's the strategy I'm going to prefer so that I don't deal with a 3-digit multiplication. Nah, I'm good. So let's go ahead and do this. 12,000 multiplied by the 18%, multiplied by 0.18. Sweet. 0 times 8, 3 times is going to be 0 3 times. Then 2 times 8, that's going to end up being 16, carry the 1. And then 1 times 8 is 8, carry the 1 is 9. So boom, we have that lined up nice and easy. And now let's do the next line where we have the 1 to take care of. 1 times 0 3 times is going to be 3 zeros. Then we have 2 times 1, that's going to be 2. 1 times 1, that's going to be 1. Add all that back up, and we're going to have 0, 0, 0, 6, 11. Carry the 1, and that is 2. Now that we're here, we have 2 decimal places, and we have 2,160. Everybody, does that represent our final answer, or does that represent what? What does that represent? Yeah, that ends up representing the growth. Exactly. That represents the growth, 2,160. So what we're going to do is we're going to add in that 2,160 because last month plus the growth gives us this month. So I'm going to end up adding that together. 12,000 plus 2,160 ends up giving us 14,160. And boom, there we are. That is this month's visitors on the website. That is going to be answer choice D. So I want to say it again and again and again. The percent and the result must represent the same thing. As long as you do that, you can navigate the formula so many nice and different ways and creative ways to get that correct final answer. All right, let's handle this next one. So the question, always, the question is to be read first. So it says, if yada, yada, yada. Remember, anything that happens after the word if, that's conditional information. So if you want to, you can just kind of skim over that and get to the actual question sentence part. The who, what, when, where, how many, which of the following, that's where you want to focus on. So how many brochures was that day's total? Now, that's a little ambiguous. That's a little unclear, a little obscure, right? I want to understand what day we're talking about because today could be Monday, but are they talking about Monday? So here, how many brochures on that day? It says if this percent were distributed on the second day, how many brochures was that day's total? So can we agree, everybody, that we're talking about the second day's total? Is that correct? We want to know the second day's total? Absolutely. So let's write that down. We want to know here blank brochures, which is the second day. Now here's what it says. It says that a station handed out 240 brochures over 2 days. Okay. If 37.5% were distributed on the second day, how many brochures was that second day's total? Oh, so this seems to be a pretty straightforward problem because we have the percent that represents the second day. 37.5%, that's the second day. Okay. So because we have the percent that represents the second day, and the original amount, 240, that means that our result will represent the second days brochures. So if you are confused right around now, typically that's going to be because you're looking at a 3-digit decimal that you're like, oh man, I don't like that at all. And then, yeah, so if we're taking a look here, it might be because of that percentage, and it might be because some new context, a new situation. And so just remember, the percent times the original equals the result. The result that we want is the second brochure or the second day's brochures. Because we want to know the amount of the second day's brochures, we want to plug in the percent for that second day. And there's that percent for the second day right here, second day. So if we plug in the percent that represents the result that we want, then we're good. We just calculate and we're done. The only issue is that we're dealing with that zero, that's going to make things a little harder. So with that, let's go ahead, turn this into a decimal, 0.375, and we're going to multiply that by 240. So let's just go ahead and get right to it. The way that I'll do it is I'll just go ahead and write the bigger number on the top, because since it has all 3 decimal places used, so I'll use 0.375, and I'll do the 240 on the bottom. If you know your little tricks, you know that you can remove the 0 and bring it back at the end, but let's go ahead and go through. So we have 5 times 0, 7 times 0, and 3 times 0. So that first part's pretty light. So I'll plug in a 0 here so I can start with the 4. So let me just put a highlighter on where I'm going to start. 5 times 4, that's 20. 7 times 4 is 28. Carry the 2 is 30. 3 times 4 is 12. Carry the 3 is 15. From there, we're going to now do the next line. And this is the complicated part. We have a 3-digit by 3-digit, and that's okay because we can practice this. So just follow along and I got you. So we'll put a 0 and a 0 so we can start right over here. So we have 5 times 2, which is 10. Then we'll carry that 1 right over here. Then we have 7 times 2, which is 14. Carry the 1 is 15. Then 3 times 2 is 6. Carry the 1 is 7. So there we are. We've completed that 3 by 3 multiplication. We have 0, 0, 0. 5 plus 5 is 10. And then 7 plus 2 is 9. And we're going to bring back not 1, not 2, but 3 decimal places. 1, 2, 3, making our final answer, the number of brochures on the second day, 90 brochures for the second day.